Welcome students. Today I will discuss the two additional chapter of polynomials where you learn about very important remainder theorem and factor theorem. You know what is polynomial, what are the different components of polynomial, what is the degree of polynomial. Looking at that, before going to start the remainder theorem and factor theorem, first I will discuss sum, difference and multiplication of polynomials. When you see that if sum, difference and multiplication of polynomials, it is obvious that when you have two polynomials, let it be gx and hx, then sum of two polynomials obviously a polynomial, difference of two polynomial be also a polynomial, and multiplication of two polynomial gives you always polynomial. So remember that each of sum, difference and multiplication of two polynomials always be a polynomial. If gx and hx are two polynomials in x and fx equals to gx into hx, then gx and hx are called factors of the polynomial fx. But remember one thing, I have not said what about the division of two polynomials. You cannot say division of two polynomials be always a polynomial. You know 0 may be a polynomial. You know 0 is a polynomial whose degree is undefined. So if let gx is a polynomial, hx is 0, then gx cannot be divided by hx. You know any expression cannot be divided by 0. So that is why in general you cannot always say that division of two polynomials be always polynomial, provided the divisor must be a non-zero polynomial. So that is why division of polynomial is differently written in this way. Division of polynomials. What about division of polynomials? Let fx and gx be two polynomials be two polynomials in X, fx is higher degree, fx is higher degree than gx, or of the same degree, then division of fx is possible by gx. So then division of fx by gx is to find the identity of the form fx equals to gx is into q plus r. What I am written, it is nothing but dividend is equal to divisor into quotient plus remainder, the very common known identity which you have learned in class 5 or so. So this is when fx is a polynomial in x and gx is also polynomial in x, and the degree of fx is either higher than degree of gx or equal to degree of gx, then the division is possible, and provided in this case gs is a non-zero polynomial, then we can find an identity of this form which is equals to fx equals to gx into q plus r, and obviously where q denotes the quotient, where q equals to quotient, and r is the remainder. You know that r is the remainder. One important thing is that here you have to remember that obviously the degree of r must be lower than the degree of gx. So here you have to remember the degree of r is less than the degree of gx. If r equals to 0, then what we can say? Then we can say fx is completely divisible by gx. When the remainder becomes 0, the division is said to be completely divisible. So that is the thing you have to remember. One of the fact that you cannot say in general the division of two polynomials is always possible, provided the divisor must be a non-zero polynomial. And when a polynomial is divided by the another polynomial, the condition are to be the degree of that polynomial must be higher or equals to the degree of gx. Then we can always find an identity of this type, which is nothing but dividend is equal to divisor into quotient plus remainder. So now I am going to discuss What is remainder theorem? Remember that remainder theorem is a special case. In this case, the divisor is a binomial. You cannot take in the remainder theorem, you cannot take the divisor as any polynomial. The polynomial must be a binomial. What is binomial? You have learned binomial is nothing but a polynomial having two terms. So first of all, we will go through the statement of this theorem, remainder theorem. Remainder theorem. What is the statement of this theorem? Statement of the theorem says that if a polynomial f(x) is divided by a binomial of the form x minus h, the remainder is fh. Very simple statement. When a polynomial fx is divided by a binomial of the form x minus h, the remainder is fh. Now I am going to discuss how can you prove that. Let qx be the quotient and r be the remainder. R be the remainder, independent of x. When r is the remainder which is independent of x, that means a constant. When fx is divided by x minus h, I have already stated what identity you will get. Therefore, what we can write? Fx equals to x minus h into qx, the quotient plus the remainder. Quotient plus the remainder. Now taking x equals to h in the above equation, what we will get? Taking x equals to h in the above equation by above identity, we get f of h equals to h minus h into qh plus r. Clearly see that this term becomes 0, so 0 into qh plus r, so that implies r equals to fh. R equals to fh. So that completes the proof of this theorem. Then you have proved that the remainder is fh. But I am writing an additional line, so you can express, but we can express fx as fx equals to x minus h into qx plus, instead of writing r, you can write fh. that completes the remainder theorem. Now I am going to discuss factor theorem. You can say that factor theorem is nothing but it is the corollary of that theorem. Corollary of the theorem. So factor theorem statement is slightly different. I have already told if h, that is the remainder, becomes 0, then x minus h can be said is a factor of fx, but its statements have a has a opposite line. That means when x minus h, when x minus a, when you take x equals to h, then you clearly see that the polynomial vanishes. So the statement of the factor theorem is that factor theorem, follow this, all the problems are from remainder theorem and factor theorem. Statement of the factor theorem state that if fx is a polynomial in x and h is any real number, then number 1, x minus h is a factor of fx if fh equals to 0. The reverse statement is that, and if h equals to 0, then if h equals to 0, no, if x minus h is a factor of fx, then fh equals to 0. You can write these two lines in a complete sentence. How? The equivalent statement is x minus h is a factor of fx. I have written I double f. No mistake is there. If fh equals to 0. Actually it is nothing but if and only if. X minus h is a factor of fx if and only if fh equals to 0. If and only if one means implied and implied by. That means x minus h is a factor of fx if fh equals to 0, and conversely when fh equals to 0, then x minus h is a factor of fx. Now proof of this theorem, one can write two different statement, two different line, or a single line for factor theorem. In a single line you can write if fx is a polynomial in x and h is any real number, then x minus h is a factor of fx if and only if fh equals to 0. So now I am going to prove this theorem. Now I am going to discuss the proof of the theorem. From the remainder theorem, we get when fx is divided by x minus h we get when fx is divided by x minus h, fx equals to qx into x minus h plus fh. Now if fh equals to 0, then fx equals to qx into x minus h. In the very first topic where I am discussing the sum, difference and product of two polynomials, I already told when a polynomial is expressed as a product of two polynomials, then one polynomial is these two polynomials are said to be factors of fx. So therefore from here you can comment that x minus h is a factor of x minus h. Again, fx equals to qx into x minus h plus fh. Then x minus h is a factor of fh. When x equals to h, if h equals to q into x into x minus h minus h plus r. So the remainder is here fh. So in this case it will be factor when the remainder becomes 0. So that means when r equals to, that is fh equals to 0, that means the polynomial vanishes for the real number h, then x minus that real number must be a 0. So then x minus h is a factor of fx. As simple as that. By you can see that factor theorem is come from the remainder theorem. So when if x equals to h, you will get the remainder is fh, and you have already said one polynomial is completely divisible by another polynomial, then the remainder must be 0, and when the remainder is 0, then we can say the divisor is a factor of that dividend. So that is why when the polynomial vanishes for the real number h, then x minus h is a factor of fx. So that completes the factor theorem. Now I am going to discuss few problems from your board book depending on factor theorem. Factor theorem, from the factor theorem, one of the important thing is that you have to remember, you know the 0 of a polynomial. How many 0 or zeros of a polynomial is there are there as the degree of the polynomial as the number of the zeros. If fx is a polynomial in x of degree n, then fx has n number of zeros, n number of zeros. That means fx vanishes for n real numbers. In future, the concept is converted to roots of an equation. If you have a quadratic equation, then the solution of that equation, that is the roots of the equation, will be 2. If you have a cubic equation, the solution of that equation by roots of the equation will be 3. So zeros of polynomial is converted to roots of the equation. So when a polynomial is equals to 0, then it becomes a equation. When a polynomial is equals to 0, then it becomes an equation. So looking at the board book, very simple type problems are there. I just mentioned how to solve them. First of all, in the very first question of exercise 7 point, I think exercise 7.3 and 7.3 and 7.4 is under the syllabus of revision test, are that so 7 problem from question number 1 of, let it be 4, 7 point, let's work out 7.3. You are asked to find the remainder of the expression x cube plus minus 3x square plus 2x plus 5 when it is divided by 2x plus 1. So in the very right hand side, first of all, 2x plus 1 equals to, right, 2x plus 1 equals to 0. You have to express that binomial of the form x minus h. How is it possible? Actually, it is x minus of minus half. So that is why solve for x from here, x equals to minus half. Let the expression as a polynomial of a in x by fx, let fx equals to x cube minus 3x square plus 2x plus 5. So next, what you have to do? You have to check if f minus half vanishes or not. If it is vanishes, then there is no remainder. If it gives some value, then that value will be the remainder. So clearly substituting the value in the expression, the value of f minus half will be minus half cube minus 3 minus half square plus 2 minus half plus 5. After simplifying, you will get minus 1 by 8 plus it will be square minus 3 by 4 minus 2 by 2 plus 5. Ultimately it gives LCM will be 8. LCM will be 8. 1 minus 1 minus 6 minus 8 and plus 40, that is 25 by 8, and the value will be 3 whole 1 by 8. So you have to write the answer in a complete sentence. So therefore, when x cube minus 3x square plus 2x plus 5 is divided by 2x plus 1, the remainder is 3 whole 1 by 8, and that completes the solution of this problem. Now I am going to discuss another problem of from the exercise, which is let the problem number 4. This problem is from the factor theorem. When a polynomial 4x cube plus 4x square minus 6 minus 1, then we have to verify 2x plus 1 is a factor of has a factor 2x plus 1. So that means here again you have to check 2x plus 1. Check now, you have to write if 2x plus 1 equals to 0, that gives x is equal to minus half. You have know the statement of the theorem, 2x plus 1 will be factor of the given expression if of minus half equals to 0. So then let fx equals to, the expression is 4x cube plus 4x square minus x minus 1. Now f of minus half equals to 4 minus x cube plus 4 minus x square minus half plus 1. After simplifying, you will get, it gives you 4 into minus 1 by 8, that is minus half. That gives you 4 into 1 by 4, that is 1. It is minus half plus I am wrongly written, it is minus 1. So the value will be exactly 0. So then we can comment that 2x plus 1 is a factor of 4x cube plus 4x square minus 1. Or conversely, we can say that this expression is a multiplier of 2x plus 1. So these are the problems from the board book. I also give the solution of number 6. Solution of number 6. Here the two expression is given, two polynomials are given. First, if you divide the first expression by x plus 2, the remainder is capital R1, and when you divide the second expression by x minus 2, the remainder will be R2. So then how can you express the relation between R1 plus R2? Actually it is given, you have to show 2R1 plus R2 equals to 6, then you have to find the value of P. So first of all, write let fx equals to x cube plus 2x square minus px minus 7 and gx equals to the second expression x cube plus px square minus 12x plus 6. Now in the right hand side try to write x plus 1 equals to 0. That means you have to substitute x equals to 1 in the first polynomial to find its remainder, and again x minus 2 equals to 0, that gives you x equals to 2. So therefore the remainder for the first case, that means when fx is divided by x plus 1, the remainder will be clearly f minus 1. So f minus 1 is minus 1 whole cube plus 2 minus 1 square minus p into minus 1 plus 7 minus 7. So remember that expression will be come out in terms of p. ভার্বালি করে নিলে এটা দাঁড়াচ্ছে p minus 6. So what you can write, fx when fx is divided by x plus 1, the remainder is r1 equals to p minus 6. Similarly, calculate g of 2. G of 2 gives you 2 cube plus p into 2 square minus 12 into 2 plus 6. So it gives you 8 plus 4p minus 24 plus 6. After simplifying, you will get 4p minus 10. So again you can write when gx is divided by x minus 2, the remainder is r2 equals to 4p minus 10. So you have find the value of r1 and r2. What is given, the relation between r1 and r2 is given here. So given that 2r1 plus r2 equals to 6. So 2 into, you have written r1 as p minus 6, substitute the value, r2 is 4p minus 10 which equals to 6. So find the value of p from here, 2p minus 12 plus 4p minus 10 equals to 6. So that gives you 6p equals to 6 plus 22. So that gives you p equals to 28 by 6. So 14 by 3, that means 4 whole 2 by 3. So the value of p is 4 whole. So the value of p is 4 whole 2 by 3. One of the very important problem from this exercise, which has repeatedly given in the exam, is number 8. Now I am going to give the solution of number 8. Number 8, what is given? Given that fx equals to a into x minus b by a minus b and b into x minus a by b minus a. Then you have to show f a plus f b is equal to f a plus b. Remember that this problem does not depend on factor theorem and remainder theorem. Just you have to substitute the value of x by first time a, next time b, and lastly a plus b. So solution of this equation, f a equals to a into a minus b by a minus b plus b into a minus a by b minus a. Clearly a minus a gives you 0. You can cancel these two terms. So the value of fa is equal to a. Put it number 1. F of b is a into b minus b by a minus b plus b into b minus a by b minus a. So again you will see that this gives you 0, 0 plus b equals to b. Now if a plus b, this equals to a into a plus b minus b by a minus b plus b into a plus b minus a by b minus a. So from here b cancel each other, a cancel each other. What you will get? A by a minus b, sorry, a square by a minus b plus b square by b minus a. To make common denominator, you can write this after taking minus as common, b square by a minus b. So that clearly the LCM will be a minus b, and this is very known thing, a square minus b square, which can be expressed in this way using the formula. So what we will get? It is nothing but a plus b. You have already proved that in the first expression the 1 plus 2 gives fa plus fb as a plus b, and obviously which is equals to f of a plus b. Proved. This is very simple problem, but this problem has given several number of times in the exam. Now I am moving I additionally give the solution of another problem of this type. The problem is like this. If the question is, if fx equals to x plus a by x plus b, then show f ab equals to f0 by f1. This is also very similar kind of problem. It can be considered to be a short type question. Just as the expression is this, calculate the value of f0. Here f0 equals to, clearly substitute the value 0 in place of x, it is nothing but a by b. What is the value of f1? It will be 1 plus a by 1 plus b. Now calculate fab. fab will be ab plus a by ab plus b. You can take common a from here, it gives you 1 plus b, it gives you, take common b, it gives you 1 plus a. So you clearly see that you can write this as a by b whole divided by 1 plus a by 1 plus b. You can express as a ratio of two fraction. Clearly you have written f a by b as f0 and f1 as this, so it is f0 by f1. Now I am moving to the next exercise, solution of the next exercise. Few problems, selective. I give you the solution of selective few problems. That is 7.4. 7.4. Problem like number 3. For what value of k the expression 2x to the power 4 3x square plus 2kx square plus 3x plus 6 is completely divisible by x plus 2. In the previous classes, what you have done, you can give the answer of this question by simply by dividing the given expression by x plus 2. Obviously you will get a remainder. As you know, when one expression is completely divisible by another expression, the remainder must be 0. So making that remainder equals to 0, you can able to find the value of k. But here I am going to solve this problem using the remainder theorem. So to solve this problem, that is, let's work out 7.4, problem number 3. Let fx equals to x plus 2 and gx is equal to 2x to the power 4 3x cube plus 2kx square plus 3x plus 6. Now you know what to do. Fx equals to 0 implies x plus 2 equals to 0 or x equals to minus 2. When gx is completely divisible by fx, then we say gx is a factor of fx. Using factor theorem, gx fx is a factor of gx if f of minus 2 equals to 0. F of minus 2 is nothing but the remainder part. You can recall from the remainder theorem. Remainder should be vanishes. So from here you can able to find the value of k. So that implies 2 into minus 2. I have substituting the value. Expression is 2x to the power 4. 3 into minus 2 whole cube plus 2k into minus 2 square plus 3 into minus 2 plus 6 equals to 0. Now solve for k. It will gives you 32 minus 24 plus 8k minus 6 plus 6 equals to 0. So 8k equals to minus 8. So k equals to minus 1. So the value of k is minus 1. That means in complete sentence you can say that when k is equal to minus 1, then x plus 2 is completely divides the expression, given expression. Now I am going to give the solution of number 5. In this case you have to find the value of a and b, where it is given that x square minus 4 is a factor of the given expression ax to the power 4 plus 2x cube minus 3x square plus bx minus 4. Let fx equals to ax to the power 4 plus 2x cube minus 3x square plus bx minus 4, and gx is equal to x square minus 4. When gx is equal to 0, that gives you x square minus 4 equals to 0, and you know the solution of x will be here plus minus 2. Now gx is a factor of fx, then f of plus 2 equals to 0, and then so that f of minus 2 equals to 0. So you know you have two unknowns, you have to find the value of a and b. So that is why you have two equations. As many number of unknowns, as many number of equation is required. So f of plus 2 0 gives you 16a plus 16 minus 12 plus 2b minus 4 equals to 0, and this gives you 16a minus 16 minus 12b is equal to minus 4 equals to 0. So finally simplifying these two equations, the equation number 1 becomes 8a plus b equals to 0. Put it number 1, and from here you will get 8a minus b equals to 0. You know the several methods to find the solution of simultaneous equation. It may be method of elimination, method of comparison, method of cross multiplication, method of substitution. You generally like method of elimination. Just adding 1 and 2, you will get the value of b as minus 8 and a is here 1. So that is the kind of problem you will face, but there are few more standard problems now, which I am going to discuss. The problem like x minus a is a common factor of two polynomials bx square plus cx plus d and b1 x square plus c1x plus d. Then you have to show that this relation a into b minus b1 is equal to c minus c. That is very simple, but how to solve? X minus a is a common factor. That means if you consider this as fx and this as gx, then fa must be equals to 0 and ga must be equals to 0. So from here, just start with x minus vanish a minus x minus a equals to, right, x minus a equals to 0. From here you will get the value of x is equal to a. So let fx equals to bx square plus cx plus d and gx equals to b1x square plus c1x plus d. So then calculate f of a. F of a will be a square b plus ac plus d and g of a will be a1 sorry a square b1 ac1 plus d. Now you know, using factor theorem f of a equals to 0, that implies a square b plus ac plus d equals to 0. So from here and a g of a equals to 0 gives a square b1 plus ac1 plus d equals to 0. Put it number 1, number 2. 1 minus 2 gives a square b minus b1 a c minus c1 d will vanishes. So again, taking a as common, what will get? A into b minus b1 plus c minus c1, this equals to 0. So in the next line you can write a into b minus b1 plus c minus c1 equals to 0. So finally what you will get? A into b minus b1 is equal to c1 minus c. One important thing is that when you use the factor theorem and remainder theorem to solve any type of problem, you have to mention using factor theorem, using remainder theorem. You have to mention that. For example, you are asked to find the remainder of a expression when it is divided by a binomial x plus 2. Let the expression is fx. You know f of minus 2 will be the remainder. Just writing that before, write this using remainder theorem. We know when fx is divided by x plus 2, the remainder is f of minus 2. Then calculate the value of f of minus 2. Remember that thing. If you don't mention using remainder theorem, using factor theorem, number may be deducted. Now another type of problem I can discuss from the polynomial. This is very simple. If fx equals to x square plus bx plus c and f0 equals to 2, f1 equals to 3, f of minus 1 equals to 1, then find the value of f of minus 3. Clearly see that here the expression is a quadratic expression or polynomial of degree 2, but the constants are unknown. There are three constants a, b and c. We generally write a polynomial in the decreasing power of the variable. The power of the variable is here 2, 1 and 0. So using these three information, your first task will be to identify the value of a, b and c. So then the polynomial will be of the known form. So solution will be in this way. fx equals to x square plus bx plus c. So therefore f0 equals to 2. That gives you, substitute the value of 0 in place of x. So that from here you will clearly see that the value of c is 0. When you put x equals to 0, the expression reduced to only c. So value of c is equal to 2. Put it number 1. Now f of 1 is equal to 3. So that means substitute the value of x as 1. So a plus b plus c is equal to 3. But you know the value of c is 2. So a plus b will be then 2. Put in number 2 using 1. Using 1 we can write a plus b is equal to 2. Now f of minus 1 is equal to 1. So f of minus 1 means a into minus 1 square plus b into minus 1 plus c is equal to 1. So that becomes a minus b plus c is equal to 2. Again 1. Again you substitute the value of 2. So that gives you a minus b is equal to minus 1. Put it number 3. So now adding 2 and 3, b is eliminated. So 2 times a is equal to, again I am a is equal to, if you substitute the value of c is equal to, so it will be 1. Adding 1, 2 and 3, you will get twice a is equal to 0. So from here a equals to 0, and so therefore b equals to 1. So the expression becomes so therefore the polynomial, therefore fx equals to only 0 into x square plus 1 into x plus 2, that is only x plus 2. So the value of f minus 2, value of f minus 2, value of f minus 3 will be then minus 3 plus 2, that is 1. Now I am going the last problem of this topic, polynomial. Let the question is, find the form of the polynomial fx when f0 is equal to 1, f1 is equal to 1, and f2 is equal to 3. So one question must arise in your mind, sir, you have not given the expression, so how can you find the unknown polynomial? One of the important things you have to remember, you have written a nth degree polynomial, in x as in this way. This is the very first topic of polynomial, and don't forget to mention a n not equals to 0. If you are asked to write a second degree polynomial, you can write this. If you are asked to a third degree polynomial, you can write this. If you are asked to write a first degree polynomial, you can write this. So every time you see that as the degree of the polynomial, the number of unknown constant is one more. That means if here it is a polynomial of degree 1, but there are two unknown constant a and b. Here it is a polynomial of degree 3, it is a polynomial degree 3, but it has 4 unknown constant. Again, it is a polynomial of degree 2, but it has 3 unknown constants. And in general, I am written a polynomial of degree n. Now count the number of unknown constant. Your count start from a1 to an clearly gives you n constant, but a0 is also constant. So for nth degree polynomial, number of constant is n plus 1. Now in the given question you are given 3 equations. In the given question you are in the question you are given 3 equations, and you know as the number of equation as the number of unknowns, as the number of equation as the number of unknowns. So that is why using this information you can able to find the three unknowns. Again, a polynomial of degree 2 has 3 unknown constant. So to start with the problem, so you have to assume the given expression as a polynomial of degree 2, as here it is given that three equation by which we can able to find three unknowns. So start the solution of this equation in this way. Here only three values of the function are known, and we can find three unknown values from these three equations. Again, a polynomial of degree 2 has three unknown constants. Therefore, we may consider the polynomial function fx, to be a ना लिखो to be of degree 2, second degree polynomial assume করে নিলে, suppose fx equals to x square plus bx plus c. So now use the information. So here the form of the expression is not given to you, but using the concept of the polynomial you can assume what should be the form of the polynomial. In this case it is a second degree polynomial. A second degree polynomial can be written in of the form, now if 0 equals to 1, that implies c equals to 1. If 1 equals to 1 gives you a plus b plus c equals to 1, and again since c is equals to 1, so a plus b equals to 0. This is equation number 1. And if 2 equals to 3, that implies 4a plus 2b plus c equals to c. Since c is equal to 1, so 4a plus 2b equals to 2, or 2a plus b equals to 1. So now 1 minus 2 gives 2a plus b minus a plus b as 1. So from here you will get a equals to 1. So since a is equal to 1 and b must be equals to minus 1, you have identified the value of b, a and c. So the required expression of the function fx is fx equals to, substitute the value of a which is 1, x square b is minus 1, x plus 1. Without given the expression, form of the expression, you can able to find the unknown polynomial function when you are given three values of the function. So that is end of the topic polynomial. I think I can able to cover all the topics of polynomial for the revision test. So that's all. Thank you.